now we have Stephanie Holbert, a PhD candidate, who is going to be presenting on
contaminants in Chinook salmon. Okay. All right, thank you everyone for coming. So I added this slide last minute because I looked at the presentations yesterday and we were talking about the blackfish effect and the Free Willy effect. And I wanted to confirm that the Free Willy effect is real. If there was a picture, if there was a definition in a dictionary and there were pictures, my picture would be next to it. So the picture on the right is me at the Oregon Coast Aquarium in 1996. I went there when Keiko was being rehabilitated to be released back into the ocean. Yeah, so whenever the movie came out, I went and watched it in theaters, and whenever it came out in VHS, I almost ruined the VHS because I watched it so many times. And after that, I was hooked on killer whales, and as my dad has said for the past 30 years, it was all downhill from there. So before I begin my presentation, I would like to make a First Nations land acknowledgement. Not only are the land that we're on today is the ancestral land of the Coast Salish people, but my research and my university that I go to at Simon Fraser University in Vancouver, BC, is on the unceded and traditional territories of the Peshitit, Squamish, Tsleil-Waututh, Coquitlam, and Musqueam First Nations. So today I'll be discussing some of my preliminary research of my PhD research. Contaminant concentrations among priority Chinook salmon consumed by northern and southern resident killer whales vary with diet and migratory distribution. So the main driving force of my research is, of course, the southern and northern resident killer whale population. As we all know, the southern residents are a very small endangered population that has exhibited or experienced declining population growth the past several decades. Two of their main threats, of course, are the reduced quality and quantity of their main prey, Chinook salmon, and high contaminant levels. And as compared to their northern neighbors, the northern resident population, the northern residents have experienced significant population growth over the past several decades, even though they can also mainly consume Chinook salmon. And they have lower level contaminant levels than southern resident killer whales. So the contaminants I'll be discussing today are polychlorinated biphenyls, or for short PCBs, and polybrominated diphenyl ethers, or PBDEs. And so PCBs were first introduced into the environment in the 1920s, and they were banned in the 1970s. PBDEs were introduced in the 1970s and were just recently banned in a complete ban in 2013. And what's unique about these two chemicals over here on the right, I won't get into too much of the chemistry, but their chemical properties are unique because there's a potential for them to have 209 different congeners or 209 different versions in the environment. And so each version is unique. So depending on how many chlorines are on each of these benzene rings or how many bromines are on each of these benzene rings, will give you a different version of the PCB or PBDs. So why are these a concern for Chinook and resident killer whales? Well, they're persistent in the environment, so they're really hard to break down in the natural environment, and they're really hard to break down once animals consume them. They bioaccumulate in animals as they age, and then they also biomagnify up food chains. So the picture on the right shows an example of how once PCBs are released into the environment, how they start off in small concentrations in phytoplankton, and they increase each level of the food chain to the highest concentration in our resident killer whales. And finally, both of these chemicals or contaminants are toxic to Chinook salmon and resident killer whales. So they can cause disruption to their immune system, their endocrine or hormone system, and also cause reproduction disruption. And studies have shown that the northern and southern residents exceed health effects thresholds based on their PCB and PBD concentrations. So we believe that they are having negative effects in relation to their contaminant levels. So because the southern resident killer whales are extremely endangered and we don't want to stress them out any more than they already are, but we still want to characterize their contaminant exposure, we look to their main prey source, Chinook salmon. So as we all know, that southern residents value Chinook salmon over all the other Pacific salmon species, most likely because they're the largest salmon species, they're the fattiest, so they have the highest nutritional value. And they're also they're easier to regularly sample than the endangered southern residents. However, Chinook salmon, as we all know, there's many populations of them in Canada and the US that are also endangered or threatened. And part of my research is also trying to focus on and fill the knowledge gap of contaminant information from Chinook originating from Canadian rivers. So my supervisor, Dr. Tanya Brown, started the Marine Mammal Ecotoxicology Lab out of West Vancouver, BC, through Department of Fisheries and Oceans, Canada. And starting in 2018, we've worked with a number of different partners to collect Chinook heads. So as I said, many of these Chinook that we're interested in are also threatened or endangered, so we do not want to take any more Chinook than need be. So we decided to take the Chinook head that usually no one wants, but the muscle at the back of the head has a lot of important information. So we've gotten samples from the Albion test fishery, which takes Chinook in the Fraser River. And then we've collect heads from sports fishermen at Port Renfrew and Vancouver Island. And then we're partnering also with a PhD student at UBC to collect Chinook heads. So based on northern and southern resident feeding studies, we selected the following 10 Chinook stocks. So once we collected the heads, we were able to do DNA analysis to determine which Chinook is part of which stock. So we have a few US stocks, but mainly most of these are Canadian. So the Fraser River salmon are South Thompson, Harrison River, Upper Fraser, and Middle Fraser. So our combined method approach, we analyzed total PCB concentrations and total PBDE concentrations, and then we used dietary tracers known as stable isotope analysis. We looked at carbon stable isotopes and nitrogen stable isotopes. What the nitrogen stable isotopes are going to tell us are the Chinook's relative trophic position within the food web, and then our carbon stable isotopes are going to tell us approximately where they're feeding, so if they're feeding closer to shore or if they're feeding offshore. And then we looked at their historical marine rearing, or where they spend their time once they leave their natal rivers to grow and mature before they come back to spawn. And then one of the final methods I used is a statistical method called principal component analysis, which pretty much, since we have all this data, it's categorized as multivariate data, so it just condenses down all of the data, and we're able to visualize and look at groupings, if there's any groupings or differences among the 10 Chinook stocks. Okay, and then this figure we used a variety of background research, tagging information, and known marine rearing to kind of visualize the marine distribution of the 10 different stocks. So here on the right, we have a group of far north migrating Chinook. The Columbia is unique in of itself. They have a lot of different marine rearing life histories, but the ones that we collected have this kind of coastal marine distribution, but a little bit far north. And then we have our offshore Chinook stocks, and then the shelf resident marine rearing Chinook in red. And then this picture over here on the left shows the areas where we collected Chinook heads. So up here in the far, up here north end, so this is northern resident territory, and then we have here, this is Port Renfrew at Swiftsure Bay, and then various areas for fishing tournaments, and this 7 right here is Vancouver, where we had collection in the Fraser River. So some of my initial results, this is the differences we saw in their dietary tracers or their carbon and nitrogen stable isotopes. So in this graph we have carbon on the x-axis and nitrogen on the y-axis, and each of the 10 stalks are color-coded. And the main differences that I want you to take away from this is that we found that the nearshore or resident marine rearing fish had higher carbon-13 values, indicating that they're feeding closer to shore, they're feeding closer to urban environments, compared with the lower carbon-13 of our offshore or far north migrating Chinook salmon. Now getting into the contaminants, this graph shows the 10 Chinook stocks ordered from offshore or far north marine rearing all the way to shelf resident. The PCBs are color-coded in purple, and then the PBDs are color-coded in yellow. And what we found is that the shelf resident rearing Chinook stocks had much higher total PCBs and PBDE levels than our offshore Chinook stocks. And in addition, these shelf resident marine rearing salmon also had a much lower percent lipids than the offshore stocks. But a bright point that I want to put out is we compared some of these concentrations to previously measured Chinook populations and found that our numbers are indicating that some of these concentrations are going down over time. So this is the PCA that I was talking about. I know it's very confusing, but what I want you to focus on is, so this is looking at the different PCB congeners and the different signatures. So what a PCA is going to show you, I want you to focus on, so it's the same data, but this figure A is going to show you how the PCB patterns are showing up on individual salmon and on the different stocks. So the stocks are color-coded. And then over here on the right is the PCB concentrations. So what we found is that the shelf residents over here, so Puget Sound, our East Coast Vancouver, and Harrison had a heavier PCB signature. So whenever I mentioned the PCB congeners have 200 different 9 congeners. So depending on how many chlorines are on each of those benzene rings will indicate how heavy each of those are. So the PCBs that have 5 or more chlorines are heavier, and the ones that have 5 or less are lighter. So when they're emitted from their source, the lighter ones are going to travel farther than the heavier ones. So think of the heavier PCBs as a bowling ball and the lighter ones as a baseball. So you can throw a baseball much farther than a bowling ball. So what we found is that the shelf residents are obtaining their contaminants from a more land-based pollution than our offshore migrating Chinook stocks. And then we finally used the dietary tracers and the PCB and PBDE information to try and do some cluster analysis for future contaminant differentiation and trying to understand if this relates to all contaminants or not. So what we found is that the shelf residents grouped together. The Columbia, again, is its own unique cluster we found, and that the offshore and far north migrating Chinook cluster together. So in conclusion, to remind you of the high points, we found that the Chinook diet and their marine distribution is making a difference in their different contaminant profiles. So the shelf-resident marine rearing Chinook had higher contaminant levels, so they're feeding on more contaminated prey. They have lower lipid content, and then the far north and offshore rearing Chinook had lower contaminant levels, and they have higher lipid content. Unfortunately, these upper and mid-Fraser Chinook stocks, which are the offshore marine rearing, are the ones the southern residents most prefer to eat because they have the highest lipid content, but unfortunately they're the most endangered. So what we hypothesize kind of towards the end of looking at all of this data is that because the southern residents aren't around during their in their summer core habitat, when the upper and mid-Fraser salmon should be coming back to spawn, they're shifting their prey base and they're coming back whenever the shelf residents are coming back to spawn, and they're eating these lipid poor, higher contaminant levels Chinook salmon. So the following steps I'll take after continuing with my PhD research, I'm going to investigate the differences among a variety of other contaminants, and then use that information to work on calculating contaminant body burden of these different Chinook stocks to estimate the killer whale intake and try and estimate how much contaminants the southern and northern residents are intaking. And then one of the final goals of my PhD is to try and prioritize the top 3 to 5 contaminant classes to bring to policymakers in Canada for more direct mitigation efforts. I don't know what time it is, but I'll take any questions if we have time. Oh, yeah, that's definitely a possibility because, let's see, looking at the map. So yeah, Puget Sound's really tiny, but yeah, Puget Sound is a historically PCB contaminated little estuary, unfortunately. And that's where some of the Puget Sound salmon do their marine rearing within Puget Sound and never leave. And then, of course, some of the Harrison spend their time in that Strait of Georgia area and in Puget Sound as well. Question?
Hi. So I know that the Albion test fishery, the fish are counted via gill net, and I'm wondering if you know what they do with the bodies afterwards, if they harvest any milk or eggs, since those fish are not able to spawn. You know the answer to that?
Right. So, excuse me. I'm not for sure if they harvest the I'm not sure if they harvest any of the eggs or I know they do. There's a limit on the daily amount that they can take, and then they do different sizes as well. So there are like different management things, so they're not just taking all that they can. And there's different times that they are able to capture and do fishing. But yeah, I'm not for sure about the eggs and stuff. That one?
I'm wondering if you or anyone else in your lab has been looking at microplastics?
So my advisor, Dr. Tanya Brown, she's a superstar. I just want to point that out. So she's pretty much in charge of all of the different contamination work in Canada. An extension of our lab is looking at microplastics. So one of my actually lab partners, she's doing her PhD on contaminants in juvenile Chinook, and they are looking at microplastics in juvenile salmon. Not yet. No, so unfortunately no. They're there though.
A question up here. forgive me for not being terribly well versed in this, I know I should be, but if PEDs were banned in 2013, and these are flame retardants, what are we using now? Like, I know firefighters need that kind of stuff. What are we using now? And, why did it take so long for us to, realize, maybe we shouldn't be using these?
Right. So, right now, if you've heard of anything, if you've heard of the contaminant PFAS, the fluorinated chemicals, a lot of people are using those now. Those are also a persistent organic pollutant. And the reason that we have to do kind of a triage in contaminant policy is because in Canadian and US law, there's this thing called the burden of proof that's put on the government. So there's not a lot of checks and balances whenever you want to introduce a chemical into circulation. And so there's some testing that they have to do, but unfortunately the burden of proof is on the government. So like with instance with DDT, we didn't realize that it was such an issue until all of this proof kept coming out. So we have to have a whole bunch of information to then bring to government and say, okay, now you have to ban it. So there needs to be more of a front end control, that there needs to be burden of proof put on the company making it. But again, that's money, follow the money, that's all I can say. Yeah.
We have time for one more question.
One more question. No? Oh, got it.
Yeah, have you or your lab looked at contaminant levels in marine mammal samples, like from stranded animals, and used those with the Chinook samples?
I don't know if we have stranded animals. So some of our partners in DFO do scat analysis. So partners that work out of Port Renfrew, they do northern resident and southern resident scat analysis. And then we do beluga work as well. I think we probably have like stranded archive, but that's not like really a part of our lab.
Thank you.